One good examples that we apply to learn the kinematics, to master them, is the free falling motion. Free falling motion. Okay, so here you have an object, you drop the object down, we ignore the air resistance, so we assume that the object is falling down under the gravitational attraction of Earth. Okay, so in that case, the object will be accelerating down at a rate of 9.8 meter per second square. This is called the free fall acceleration. By free fall, we mean there is no air resistance. We are ignoring air resistance, which is most of the time the case. So now, going back to the kinematics equations, we replace the acceleration A by this value, 9.8, and the direction of the acceleration is always downward. Because of that, it is with a minus sign. Okay? Usually, the upward direction is considered positive, the downward direction is considered negative. So it is the same kinematic equations, we only replaced A by G and took into consideration the sign for the acceleration. It's downward. So the displacement now, as you can see, it is y rather than x. We are talking about the y-axis, the change in position along the y-axis. This is the initial velocity along y multiplied by the elapsed time minus half gt squared. G is the acceleration along the y-axis, the vertical axis. The same for the final velocity. It's along the y-axis. It's going downward. Is equal to the initial velocity minus gt. Okay. Here, a few things that I'd like to share with you. If you read the problem, and the problem says the object is dropped, the word it dropped means that the initial velocity is 0. It dropped. This is another fancy way of saying the initial velocity is 0. If it's thrown up or thrown down, then the word thrown means yes, there is some non-zero value for the initial velocity. So keep this in mind when you read the problems. Okay. Another keyword, if you throw an object up and says reached maximum height, at maximum height, the object will stop instantaneously. As it is stopped at maximum height, the velocity is 0. Wherever it says maximum height, this means the velocity at maximum height is 0. Then it will start descending back to ground. Like if you have a ball, you throw it upward, it will reach maximum height. At maximum height, the velocity, the final velocity is 0. Then it will start descending back to Earth. So these kind of keywords, you need to be aware of the significance of these keywords, make use of them when you solve problems. Okay, check your understanding. A tennis player on serve tosses a ball straight up. While the ball is in free fall, its acceleration is, what would you say?
It increases.
It increases. Okay. Any other suggestion? Okay, I will give you a tip and allow you to revise your answer. Acceleration means the change in velocity. It's not velocity. Acceleration is the change in velocity. So if you go here, what does it say? What is the free fall acceleration? It is 9.8 meter per second squared. This is a constant value. It doesn't change. It is always 9.8. It is always downward. So both magnitude and direction are constant, right? I'm talking about the acceleration. It is always constant in magnitude and in direction. The velocity will be changing. The velocity changes with time. Yes, the position will change again with time. But the acceleration is always fixed, is always downward, is always 9.8 meter per second square. So what would you say?
It remains constant.
Yes, thank you. I appreciate that. Yes, this is a very important point and a tricky point. Many students sometimes loses problems because they are not aware of this point. Wherever you see free fall means the acceleration is 9.8 meter per second square and it is downward. Regardless whether the motion is up, whether the motion is downward, whether the motion is to the east or to the west or in any other direction, as long as it is a free fall, the acceleration will always be downward and will always be 9.8 meter per second square. We understand this?
Yes.
I didn't hear you. We understand this?
Yes.
Yes.
Thank you. Another question. As the tennis ball travels through the air, its speed increases, decreases, increases, then decreases, decreases, and then increases. What would you say? Remain the same? So I will give you the tip first, then I will listen to your answer. So the ball is traveling through the air. It is traveling upward. As it is traveling upward, the final velocity is equal to the initial velocity minus gt, minus 9.8 multiplied by time. In plain English, after 1 second, when t is 1 second, the velocity would have decreased by 9.8 meter per second. We understand this equation. This will continue until at maximum height, this whole velocity is eaten away and the final velocity is 0 at maximum height. Once it is 0 at maximum height, then the ball will start falling again with this acceleration toward the ground. Okay? Now back to that question. What would you say? I can say decreases, selecting this one, or decreases and then increases, depending on the time domain. If you are telling me about the whole trip, I will select this. It decreases until it reaches 0 at maximum height. Then it starts increasing as it descends down to ground. Okay, so this would be the picture. But if you are interested in just the very short period of time after releasing the ball, then I will say yes, it will continue decreasing until it is 0 at maximum height. Very well. A skydiver jumps out of a hovering helicopter. A few seconds later, another skydiver jumps out. So they both fall along the same vertical line relative to the helicopter. Both skydivers fall with the same acceleration. Yes, it has to be same acceleration. G is constant. The vertical distance between them, this is a nice question. Increases, decreases, or stays the same? To answer this question, we need to go back to the kinematics. So you have this situation. This is the change in position. The initial velocity for both was 0 because they were dropped from the helicopter. So you are dealing with this term, y equals half gt squared. Okay, y equals half gt squared for the first skydiver, then y2 equals half gt2 squared for the second diver. Have this in mind when you read the problem and try to answer it. Any suggestions? Stay the same?
Stays the same.
We all agree on that? Okay. In order to have the right answer, consider this equation and substitute some numbers. Say at the beginning, the problem says here that the few seconds later, let's say 2 seconds later, okay? So to understand, if you use 2 seconds here, square of 2 is 4, okay? If the difference between them is 2 seconds, the square here is 4. But after 10 seconds, you are talking about 10 and 12. The square of 10 is 100. The square of 12 is 144. You see? So the difference now is 44. While at the beginning, t squared was 2 squared, 4, 0 compared to 0. So the difference was 4. Okay? So based on this formula, I will choose the answer, this one, increases. You are dealing with a t square factor. If it was t, not t square, in that case, yes, it will stay the same. But you have parabolic behavior, you have t squared, so yes, it will increase. Okay? Like if you take after 15 seconds, square of 15 is 225. Compare that to 13, square of 13 is 169. 225 minus 169, this gives you 56, the difference. So as time increases, the difference gets bigger and bigger. You understand that? Okay?
Yes.
Yes.
Thank you. For the two skydivers, the difference in their velocities, in order to answer this question, let's go back to the velocity equation. So this is the velocity. V naught y is 0 for both because they were dropped from the helicopter. And the velocity is minus gt. So 9.8 multiplied by t. So if t was 2 and the other t is 0, the difference is 2. If t is 12 and the other t is 10, the difference between them still 2. If t is 20, the other t is 18, still the difference is 2, and so on and so forth. So which one you think is the right one?
Would it increase?
In this case, it will stay the same, right? 10 minus 8 is 2. 20 minus 18 is 2. 15 minus 13 is 2. The same difference. Okay, so it will stay the same. The difference in velocity will stay the same.